So if we're asked to graph this solution, actually, let me see. Yeah, I'll pull up MyLab math to help you work on the functions too, because sometimes it's tricky for students to actually plug in the graph. Okay, so before we do that though, let's get out some scratch paper. We want to graph the solution. What you want to do is graph these inequalities, so pretend they're equations, okay? Just like you've done before. Get a nice color here. Let's pretend that this is 3x minus y is equal to 1. And if we wanted to graph this equation, this one lends itself to graphing by the intercepts, right? So I call it the cover-up method. It's like if you plug in a 0 in for x, you get out y is -1, right? Because a negative -1 makes a positive 1. So I'm going to put a dot down here for -1. Color code this. Oh, I need to go back though. Okay, here's -1. Here's my dot. That was when we covered up the x term. If you plug into 0 in for y, that makes -0 or -0, so that's nothing. So 3x equals 1. Ooh, this one isn't so nice, because it's going to be a fraction. I think it's going to be a fraction either way. X equals 1/3 using the graphing by intercept. So here's a dot where 1/3 is. I don't like that though, because we want to avoid putting dots, you know, a third of the way through. That's hard to graph. I have an idea. Let's put this one in slope-intercept form, okay? Still not going to be nice though. I'll see how we can graph that. If you put this in slope-intercept form, oh, we said we're going to pretend it's an equals. Graphing it just like a normal equation. Subtract 3x from both sides, so you get -y equals 1 minus 3x. Oh, no, there's no fractions. I was looking at that wrong. So the last step here, that's -y. You can't drop that negative sign. So you get to divide everything by -1. So you get y is -1 plus 3x. So we put a dot at -1. And then the slope is 3. That means we count up 1, 2, 3, and to the right 1. Right? Because the slope was a 3, which is 3/1. And there, that'll be nice to graph in MyLab math, because those are integers. We don't have to worry about trying to get fractions in there. Okay, let's graph this one. Again, sorry, there's an important detail I kind of glossed over here. I'm very sorry about that. It's a solid line because this is or equal to. This next one over here is going to be a dotted line, okay? That's not what I want. So I got to graph again. Roughly like, yeah, come on, good enough. Yeah, so for this one it's a solid line. The next one has to be a dotted line. So we get 4x plus 2y equals 8. Let's put that in slope-intercept form. So subtract 4x from both sides. Divide everything by 2. And so our starting dot is at 4 on the y-axis, because that's the y-intercept, the number hanging out by itself. And my slope is a -2, so that's -2/1, right? Means I count down 2 to the right 1. Oh, they cross perfectly. So there's the second line. Oh, this one we said is dotted because it says just greater than, not greater than or equal to. Strictly greater than. So that's why we have to have a dot, because it doesn't have the line underneath here. Okay, and the way you find your solution is you've got to plug some values in that definitely land on like one slice of the pizza. So we have a value here. This is 3, 2. And if that value is a solution to the system, then we should shade this slice of the pie over here. Okay? But if it's not true, we got to go find another pizza slice. So the way you check that is you plug 3 in for x, 2 in for y, and see if it makes a true statement. 3 times 3 makes 9. 9 minus that 2 makes 7. Is 7 less than or equal to 1? No, it isn't. So this is not the solution side. Well, now you can pick another test point. And I guess I get to ask this a lot. Why did I pick 3, 2? I could have picked any number. You could have picked 3, 3, as long as it's on this slice of the pizza right here. If this is our pizza, pick any point in that slice. Okay? So how about 1, 5 up here? 1 on the x, 5 on the y. Let's see if that's a solution. If you plug in 1 in for x, 5 in for y, and then 3 minus 5 makes -2. -2 is less than 1, so it checks out with the first equation. But we got to try with the second equation. If you plug in 1 in for x, 5 in for y, 4 times 1 makes 4. 2 times 5 makes 10. 4 plus 10 is greater than 8, right? It's 14. So it worked for both of them. This is our solution, okay? And you can do the same for the other ones, but you're going to see those aren't solutions. Like if you try to plug in -1, 2, -1 for x, 2 for y, -3 minus 2 makes -5. -5 is less than or equal to 1. Checks out for the first equation, but if you plug it into the second equation, it gives you a false statement. Okay, and then same thing, you could check a point over here, but my solution is just this slice of the pie up here. So let's graph that, because I know MyLab math can be touchy when we graph. Click to enlarge the graphing tool. Let's see if I can move my screen over. There we go. Okay. So we want to click a point. So we have a point at 0, -1 for the blue line, and then we said the next point was at 1, 2. So there's that first graph, and we could make it dotted if we wanted, but we want this one to be solid, we said. So we need another line. Our first dot that we got was 1, 2, 3, was at 4 on the y-axis, and then another dot it was down 2 to the right 1. So there's another dot. Let's make that dotted. And we said our solution area was this area up here, so we click that bucket tool. Oh, sorry, you can't see the dotted thing. It's off your screen. But click the bucket tool, click where you want to shade, and I think that's good. I have it minimized. Save. There we go. Okay, let's see if it likes that. It likes it. Okay.